problems on operations on signal. Before getting into a problem, we'll see what the problem exactly means. So here I've taken two example, 3x minus 2t plus 4 and minus 4x plus 4t minus 5. Let's see the first one, 3x minus 2t plus 4. See, first check out what is with t. It is plus 4. When I say plus 4, it means time shifting. So there is a time shifting that has been done. Now here when we say plus 4, it is an advanced time shifting. When a plus comes, it's an advanced time shifting. Then we'll go with minus. This minus refers to times reversing with respect to the center point. Okay, and this 2 refers to time scaling. Time scaling. Now here it is 2 into t. When you say 2 into t, then it is compression. Next is the initial 3. This says that there is an amplitude scaling. Amplitude scaling. So we have a time shifting, we have a time scaling, we have a time reversal, we have a amplitude scaling. There is only one, so we just have one signal. So you have to just do the operations on one given signal. See the next example. As I said, go from the behind. It is minus 5. So you have a time delay shift. A time delay shift. Now, the advance in the delay is represented by plus or minus in front of the last number. So it is minus, so you have a delayed shift. Then comes plus. This plus denotes there is no time reversal. There is no time reversal. So you need not worry about the time reversal here. Then comes the 4. The 4 along with this t represents time scaling. Time scaling. Now here we have 4t. If we had 4 by t, this is for compression and the next one will be for expansion. So the value with the 4 will give you the time scaling. And the first one, minus 4. This is amplitude scaling. Amplitude scaling in negative direction. So this minus represents that we have to do the scaling in the opposite or in the lower part. Okay, so when you have an equation, you have everything put together. You have a shifting, you have a reversal, you have a scaling, you have the scaling for both time as well as amplitude. So when a question is given, you have to check out what all has to be done. Problems on operations on signal. The first problem. For a given x of t, you are asked to draw x of t plus 2, x of t minus 2. So from the problem itself, we know you have asked to do time shifting operation. So there is an advance shift and there is a delay shift. Okay, so this is the original signal that has been given, minus 1, 0, 1 and x of t. Now we are asked to do the first one, x into t plus 2. So when you say x into t plus 2, before that, the three instances are t is equal to minus 1, t is equal to 0 and t is equal to 1. Okay, now for x is equal to t plus 2, your t becomes minus 2. For the first instance, it is minus 2 minus 1, that is minus 3. For the second instance, it's minus 2 plus 0, that is minus 2. For the third instance, it is minus 2 plus 1, that is minus 1. So the three new instances are minus 3, minus 2 and minus 1. See the amplitude? The amplitude is nothing but 1 for all three. It's a continuous time signal. Now here you can say the signal has been advanced by t plus 2, by 2. In the next problem, you are asked to do t minus 2. For the same thing, you're going to write t is equal to minus 1, t is equal to 0 and t is equal to 1. Again, here t is equal to 2. So for the new instance, t is equal to 2 minus 1, 2 minus 0, 2 minus 1. So this will be 2 plus 1. So this will be 1, 2 and 3. So these are the new instances. 1, 2, 3. The amplitude is saved. So this is, the signal has been shifted twice to its left side. This is called advanced shift. And here it has been delayed shift. So this is the first problem. It's related to time shifting operation. The second problem is for x of n, draw x into n plus 2 and x into n minus 2. Now when you say x of n, you very well know we are speaking about discrete time signal. So this is the original signal that has been given. Take the three instances, that is n is equal to minus 1, n is equal to 0 and n is equal to 1. So these are the given three instances. For all three, the values of the amplitude is 1. Okay, so value of x of n is 1 for all the three. Now let's do the first one, that is x into n plus 2. When we say n plus 2, your n becomes minus 2. Now having minus 2, find out the three new instances. So n is equal to minus 2 plus minus 2. Just write all the three, so that will be more easier. Minus 1, 0, 1. Minus 1, 0, 1. So this gives you minus 3, minus 2 and minus 1. So the new instances are minus 1, minus 2, minus 3. And we know that all the three have the amplitude of 1. So there is no change in the amplitude. So this is your time advance. Okay, advance in time. Next, for the same instance, write for n minus 2. When you say n minus 2, your n becomes 2. So now write for all the three instances. Minus 1, 0, 1. Minus 1, 0, 1. 1, 2 and 3. So these are the new instances. 1, 2, 3. Again, the amplitude will be 1 for all the three. There is no change in the amplitude. So if a question of such is asked, you are asked to do an advanced shifting and a delayed shifting. Sketch the following. We will see two problems now. The first one is u of minus t minus 1. Now you will be given such a problem and you are asked to sketch for it. Now there is no diagram for this, because when you say u of t, you know it is unit step impulse and you know the basic of it. So this is how u of t is drawn. Okay, so this is unit step impulses graph. So this is u of t. Once you have drawn u of t, you are asked to do this whole thing. So when it says minus 1, there is a time shift, time delayed shift. And when you say minus t, there is a time reversal. So from the question, you know three things you have known. First, unit step signal is used. Then you are asked to do a time shifting and again a time reversal. Three things is asked. So first we have drawn the unit step signal. Then we will do the time shifting. So we have said one shift delay, u of t minus 1. Okay, there is one shift delayed. So instead of 0, you're going to start from 1. This is u of t minus 1. There is a delay by one shift. Okay, if you want, again you can write and see the original value of t is equal to 0. You're asked to do t minus 1. So your t becomes t is equal to 1. So now your new t becomes, the new t is equal to 1 plus 0. That is nothing but 1. That is what I have drawn here. See, that's what I have drawn here. So you have got the new signal. And now they have said time reversal. So for time reversal, what I have told you, do not change the center point but bring the signal from this direction to the opposite. So now your signal will be like this. No, sorry, the signal will be like this. T, and this is u of minus t minus 1. We do not change the center point, we just bring the mirror image. So the amplitude is 1, here it is 1, 0 and so on. So this is the final value of u of minus t minus 1 that has been obtained by a delay shift as well as a time reversal. This is how you have to solve a problem. Next given is, the second problem is x into 2t minus t. Here the diagram is given. Two operations they have asked you to do. First is time shifting and then time scaling. So when you say minus 3, that is a delayed shift, and when you say 2t, then you have a compressed image. Okay, so let's do the first part. Before starting, please take down the values of t. So t is equal to minus 3, t is equal to minus 2, t is equal to minus 1 and t is equal to 0. The first thing we are going to do for t minus 3, x into t minus 3. So in that case, your t becomes 3. So for 3, what will be the instance? So 3 minus 3, 0. T 3 minus 2, 1. T 3 minus 1, 2. And t final t, 3 minus 0, 3. So these are the new time instance. Now you can draw 0, 1, 2, 3. That's all. Okay. The amplitudes change. As you see, amplitudes don't change. I'm sorry. So draw the same amplitude. At 0, it will be like this. Then it will go on top. And then again come down. And then it will be like this. So at 3, what will be the amplitude? 1. At 2, what will be the amplitude? 2. Similarly for 1. And then it will come back to 1. So this is the new diagram drawn. Then next they have asked you to scale. So we are going to do for x into 2t minus 3. So t minus 3 has been already done. Now we are going to do the 2t part. Okay, now again the 3 instance, you know it is t is equal, no, the new 3 instance. T is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3. Don't take this because this one we have already done it. So from this only you are going to do the time scaling. So you have to take the set of instances from here. Okay, now you have taken. Now they asked 2t. So when you say 2t, t is equal to 1 by 2. Okay, so now your t becomes 1 by 2 into 0. That is 0. T is equal to 1 by 2 into 1. 0.5, 1 by 2 into 2, 1, 1 by 2 into 3, 1.5. So these are the new instance, 0, 1, 0.5, 1 and 1.5. Okay, the amplitudes do not change. So you have the same amplitude. It's 1, 2, 2 and 1. But the time changes. So this is a final diagram you have got. Here you see you have shifted your signal. Okay, you have delayed the signal. That is, you have shifted to the right side. Also, you have scaled the time by 2. So the time has been reduced. You have scaled it. So this is the final diagram. So one main thing you have to remember is, when you do the first part, take the original value of t. But when you do the second operation, take from this diagram. So you can only go step by step. So these are the two problems for operations on signal.